Baskerville Radio.
Hello. This is the audio commentary to accompany the science lesson Diffusion and Gas Pressure. You can pause this audio commentary anytime you like. First slide, diffusion and gas pressure. When substances are in the gas arrangement, in other words when they're in the gas state of matter, they have some unique properties. Scientists and engineers capitalise on or use these properties to make gases useful. Hydraulic machines use the compressibility of gases to allow heavy loads to be moved with minimal effort. Slide 3. Diffusion. Moving particles will spread out if they have space to move into. This is called diffusion. Diffusion happens even if there is no breeze or air current or wind. During diffusion, particles move from areas where they are strongly concentrated, that means there's lots of them, to areas where there are fewer of them. This means that the particles are spread out more evenly after diffusion than before. Gases diffuse easily because their particles can move freely about. Liquids can also diffuse, but diffusion in a liquid usually happens slower, and that's because their particles aren't able to move around as freely as when they're in a gas. Okay, you can see on figure 2 particles that cause smell from the smelly socks travelling through the air by diffusion and spreading out. Okay. Slide 4. How quickly particles diffuse depends on a number of factors. For example, the size of the particles. The smaller and lighter the particles are, the faster they diffuse. Temperature. The higher the temperature of the gas or liquid, the more energy the particles will have, and the faster they will diffuse. The difference in concentration between where the particles were when they started and where they are moving into, the greater the difference, the faster they will diffuse. So if there's loads of particles in one place and not many in another place, they'll move quickly or diffuse quickly. Okay? It also depends on any other particles that are in the way. They could bump into other particles which would slow the diffusing particles down. Okay, on figure 3 you can see that someone has put a coloured dye in a beaker of water, and it starts off concentrated in one place but gradually diffuses into the liquid until it's spread evenly throughout the liquid. You can see that sort of thing when you're maybe making a glass of orange squash. You put the orange in and it quite quickly spreads out till it's spread out across all the water. Next slide. Gas pressure. As gas particles move around, they hit objects. This causes gas pressure. The faster the gas particles move, the more force they exert, so the greater the pressure is. The hotter the gas, the more energy its particles have, and the harder they hit the container. Okay, so actually the hotter the gas is, the more pressure it's going to exert. Okay, and the next slide has the questions. So question 1, why is diffusion usually slower in a liquid than in a gas? And you might want to refer to slide 3 entitled Diffusion to help you with that answer. Question 2. When smell particles diffuse across a room, what are the other particles that could get in the way? So think about what other particles are in the air. Question 3. Draw a series of 3 particle diagrams to show the stages of diffusion that relate to figure 3. So figure 3 is on slide 4, and you could maybe show the particles as little circles gradually spreading out over your 3 diagrams to spread out evenly throughout the liquid. Question 4. Explain what would happen to an inflated balloon if you put it into the freezer. So if you look at slide 5, it describes what happens when a gas gets hotter. What would happen to a gas when you put it into the freezer? And have a think about the effect that would have on the pressure. Okay. Number 5. Explain how the air in a bicycle tyre causes pressure. So again, that's on slide number 5. And describe in detail what will happen to the gas pressure on a very warm day. So again, the answers you need are on slide 5 for that. Okay. Thank you for listening, and goodbye for now.
Baskerville Radio.